Discuss about Henry's law and Raoults law. So Henry's law, here we are going to deal the solution, that is the solute is in the gaseous phase and the solvent in the liquid phase. Okay, so what it is reads, the partial pressure of the solute is directly proportional to mole fraction of the solute. Okay, so and we put the proportionality constant, that is KH. The KH is known as the Henry's constant. Okay, so P solute, small p, we should not write the capital P. Capital P means it's a total pressure, small p means it's a partial pressure. Okay, so what is the mole fraction of the solute? That is number of moles of the solute divided by total number of moles of the in the solution we have only two components. What is solute and solvent? So we have to take the moles of the solute as well as the moles of the solvent, that is the total moles. Okay, so this is Henry's law. And suppose here what are the condition, the gas should not react with the solvent. Okay, so for example we take HCl in the any organic solvent, so it will not react, right? And when you just plot it, what happens, the line passes through the origin. It's because it looks like, this equation looks like y equal to mx. Okay, so when x is in the x-axis, because in the x solute it ranges from 0 to 1, right? Because it's a mole fraction, right? So mole fraction, the value ranges from 0 to 1. And y is the partial pressure, so that is in the tar. So like it ranges from 0 to 1000, for example. Okay, so the graph look like such a linear graph, linear line, it passes through the origin. Okay, and what are the limitations for the Henry's law? So Henry's law, it is applicable at the moderate temperature and pressure. So you should not use very high temperature or very high pressure or very low pressure or low temperature and so on. And the gas should be soluble, the solubility of the gas should be very low in the solvent. Okay, that means low solubility means it can create the very dilute solutions. So if it is more soluble means it can create it can produce a high concentrated solution. So Henry's law, it's not applicable for the highly concentrated solution, it is only applicable for the dilute solutions. And what are the gaseous solute that you are taking, that should not react with the solvent. Okay, so for example if you take ammonia and water, so ammonia is can react with the water and form the ammonium hydroxide, right? So these kind of reacting gaseous solute you cannot take with that particular solvent, so you should avoid that. And what are the other things? So when you are taking the gaseous solute, it should not get associated or dissociated in the solvents. So what is association? Something like when I take iodine as a solute in the Ki is a solvent, what happens, I2 and Ki forms Ki3, so it is association. Okay, so associated means Ki3 complex, so it is the solute is entering into the solvent, it can get associated. Dissociation means, for example, I2, if I am taking it some other solvents, it can become I minus. Okay, so I minus means it can getting dissociated. Okay, so when I take I2 means it should exist as a I2, it should not get I minus or it should not form any other complex. So the solute should be in the whatever the molecular state you are taking or in the atomic state you are taking, that should be in the same state. Okay, it should not get associated or dissociated with the given solvents. So this is the Henry's law. So Henry's law's special form is the Raoults law. Okay, here we take either liquid or solute, solid solute, that should be in the non-volatile state, and solvent should be, it should form the homogeneous mixture. Okay, so here we are dealing with the partial pressure of the both the components. So the partial pressure of the solute directly proportional to mole fraction of the solute. The partial pressure of the solvent is directly proportional to the mole fraction of the solvent. And here we put the proportionality constant. For Henry's law we put the proportionality constant as a KH. Here we are going to put their partial pressure in pure state, that is as the proportionality constant. Here the small p without naught means the partial pressure of the solute is equal to partial pressure of the solute at the pure state at a given temperature into X solute. Similarly, the partial pressure of the solvent directly proportional to the mole fraction of the solvent. So the proportionality constant is the partial pressure of the solvent at a pure state at a given temperature. So what do you mean by pure state? For example, if I am taking like what do you call CO2, sorry, I should not take any gases, no. So if I am taking like camphor and kerosene, so but that is volatile. For example, NaCl in water, okay. So I am measuring NaCl partial pressure. I just I just make it in the liquid state like by melting it, and so there may be the gaseous vapors in its equilibrium with the liquid surface, right? So in that time, so when it is not mixed with the water only, it is exist as a NaCl alone. That time when you are measuring the partial pressure in the liquid state or in the vapor pressure, that is known as the P naught of NaCl. Similarly, when I am taking water alone and that water vapors are in equilibrium with the liquid water, it can exert the partial pressure. So that is the partial pressure of water, okay, or vapor pressure of the water at a pure state. So when you just mix with both the NaCl and water, and when you are measuring the each partial pressure of the component, okay, so that time we just put a without naught. So when it is mixed, that time you are measuring the partial pressure, means it's simply P. So when it is not at all mixed with it, when it exists as a single component, that time if you are measuring the partial pressure or vapor pressure, that is at the pure state, okay. So here we are measuring for the solute as well as the solvent, but in the Henry's law we only dealt with the partial pressure of the solute only. Here we are measuring the partial pressure of the solute as well as the partial pressure of the solvent, and both are directly proportional to their mole fractions. So suppose if I am taking solute as A and solvent as, because it's forming a binary solution, means one solute one solvent, right? That is known as a binary solution. So when I put solute Pa is equal to P naught A into XA, similarly Pb is equal to P naught B into XB. So this is the Raoults law, and we further discuss about Raoults law and lowering of vapor pressure and relative lowering of vapor pressure, other qualitative properties and all. So that we see in the next lesson. Thank you.